So here we have an average speed camera. That's it up there. Okay, you might have seen these when you're in a car with someone and they're driving down the road, and you see they're always big and yellow like this, and there's always a sign that says average speed cameras. But do you know how an average speed camera works? Well, let me show you. So first of all, you need to remember that to know an object's speed, we need to know the distance it travels in a certain period of time. So this could be a car, it could be a rocket, it could be you running along the road. Doesn't matter what it is, you need to know two things. So the first thing is distance. So you can measure distance with a ruler or with a laser or all sorts of things you can measure it with. But the key thing to remember is that distance is a measurement. And the other measurement we need is time. Okay, so time is a measurement, distance is a measurement, and so when we're calculating an object's speed, well, speed is also a measurement. It is a measurement of how far the distance the object is traveling over a period of time. So here is a road, okay, and let's think about average speed cameras. So speed cameras, in this case average speed cameras, need to measure distance and time. Okay, because you have to do that. It doesn't matter how fancy your equipment is. At the end of the day, to measure speed, you need to know distance traveled and the time taken. So let's put our two speed cameras down. Okay, here's our average speed cameras. And when they're being built, when they're being put up like this along the road, they are put at a set distance apart. Okay, because that doesn't change. So the distance between these speed cameras is always going to be the same unless they get moved, which they're not going to get moved. So in this case, we're going to say that the measured distance that we have is 500 meters. So these speed cameras are 500 meters apart. Now, let's have a think about how this is going to work when a car comes through. Whoa, that was a bit quick. Right, let's slow this down and let's see what each camera does when the car comes through. Okay, here comes our car. Oh, it's having a wee think, and it's starting a timer. Okay, so the timer started, timer keeps going, and then it stops. Okay, the car passes the first average camera, the average speed camera, and the timer starts. It then passes the second one, and the timer stops. So let's just say for this example that the time taken for that car to travel from here to here are 500 meters. The time taken was 20 seconds. So now we have a distance that the object has traveled. We have a time that it took, 20 seconds. And so we can calculate a speed. And here's how you would do it. So how far did the car travel? 500 meters. How long did that take? 20 seconds. So to find speed, so remember, speed is how much distance is traveled over time. And that word over helps you remember how to use the equation. And this is going to be the first time you've seen this equation perhaps, but it's a fairly easy one to use. So here's our equation. Speed, S, is how much distance, D, is traveled over. There's our over. So when you see something that's over or per, that word per, so we could say it's distance per time. How much distance is traveled over time. So let's plug our numbers into this. So we've got distance and time. Now normally I would put this underneath. Okay, when you're doing your working, I want you to make sure you put it underneath, but just because of the shape of the screen here, you need to put it sideways. Speed is 500 meters divided by 20 seconds. So you might want to put that into your calculator, see if you get the right answer. Pause the video just now if you want to check. The speed is 25 meters per second. Now, well done if you got that right, if you managed to finish that off. And we know it's meters per second, and that's what this little -1 means. This little -1 is the same as having this dividing line here. It tells us that on the top we have meters, because it was 500 meters, and on the bottom it's seconds. So it's meters per second. And because seconds is on the bottom, it gets a little -1. But meters, because it's on the top, it doesn't get a little -1. So the answer was 25 meters a second. So we can say the car was traveling at 25 meters per second, or we could say every second the car traveled 25 meters.